समुद्रवसने देवी पर्वतस्तनमण्डले विष्णुपत्नि नमस्तुभ्यं पादस्पर्शं क्षमस्व मे.
The idea of worshipping nature in all its forms has been the bedrock of Indian spiritual teachings since time immemorial. It is also a part of the Oriental character that spirituality and science have a deep-rooted relationship. It is this bonding that gives it a hue distinguishing it from any other civilization across the globe. The need to harness water resources was never lost upon the community. The coming together of progressive thinking and some of the most sparkling scientific minds became the seed for the Central Water Power Research Station, CWPRS, in Hadapsar, Pune in 1916.
It owes much to the enlightened and inspiring leadership given by men of international standing like Sir Claude Inglis, K.K. Framji, D.V. Joglekar, and their successors. The institution was taken over by the central government in 1936.
The post-independence growth of the institute is truly remarkable. The CWPRS today, situated at picturesque Khadakwasla, 18 kilometers southwest of Pune city, is spread over 490 acres of land. It is also propped up by a reservoir, Khadakwasla Dam. To those gifted with a scientific temperament, the pathway to realizing a personal yet universal milestone is by service through research. The CWPRS of today is the central agency catering to research and development needs in water and energy resources development and waterborne transport. It is also a jewel in the crown of the Ministry of Water Resources,
River Development and Ganga Rejuvenation.
केंद्रीय जल एवं विद्युत अनुसंधान शाला की 100 वर्ष पूरे हुए। जब भी हमें विकास में कोई नया आयाम लाना होता है तो अनुसंधान जरूरी होता है और इस दृष्टि से हमारे इस संस्थान ने बहुत महत्वपूर्ण योगदान दिया है देश के विकास में और खास करके जल के क्षेत्र में। अब 100 वर्ष पूरे हो रहे हैं और ये 100 वर्ष पूरे होने के लिए मैं बधाई देती हूँ और साथ में मानती हूँ कि अभी तक जो भी ज्ञान का संग्रहण हुआ है ये भविष्य में भारत के विकास में और खास करके जल के क्षेत्र के विकास में ये महत्वपूर्ण भूमिका अदा करेगा। मैं इसमें काम करने वाले सभी लोगों को जिन्होंने 100 वर्षों तक इसको सफलतापूर्वक चलाया, इसकी अपनी एक प्रतिष्ठा है, इस अनुसंधानशाला की एक सम्मान है, देश में और दुनिया में एक नाम है। इस नाम को जिन्होंने अपनी तपस्या से, अपनी साधना से, अपने सहयोग से बरकरार रखा, उन सबका मैं बहुत बहुत अभिनंदन करती हूँ और आगे हजारों हजार वर्ष की आयु के लिए अपनी शुभकामनाएं देती हूँ।
Within India, the CWPRS has taken the realm of managing water resources to a surpassing level.
केंद्रीय जल विद्युत अनुसंधान शाला विगत 100 वर्षों से लगातार कार्य कर रही है। इसके परिणाम स्वरूप आज दुनिया के अंदर हमारी इन सर्विसेज का अग्रणी स्थान है। मैं आशा करता हूँ कि आने वाले समय में और लेटेस्ट टेक्निक का इस्तेमाल करते हुए ये अपना स्थान बरकरार रखेंगे और जनहित के कार्य जनता के लिए करते रहेंगे। इनका आज भी हम असर देख सकते हैं जल और विद्युत का कि इस देश के आम लोगों तक ये सुविधाएं पहुंच रही है। इसके अंदर पुणे स्थित इस संस्थान का बहुत बड़ा योगदान है।
The Indian monsoon supplies water to all Indian rivers.
Hydrometeorology deals with the hydrological issues, runoff, infiltration, erosion, flooding and water resides in water bodies, which is an after effect of meteorological processes such as rainfall and evaporation.
The great Indian Himalayan rivers like the Koshi and the Yamuna provide water to riparian areas, but often cause heavy floods and erosion, calling for disaster management. It is the CWPRS, with its meticulous model studies, that helps design bank protection works to tackle the menace of erosion. The CWPRS is situated at the foot of the Khadakwasla Dam. 120, 100 and 60 cusecs of water needed to run the physical models is taken from the Mutha Canal. This arrangement has been designed by scientists of the CWPRS team.
River Kosi drains the geologically most fragile area of Himalaya near Mount Everest and Kanchenjunga. It brings in large quantity of sediment along with water, leading to its frequent change in course. The river has moved laterally by about 120 km in 230 years. To train this river and to moderate the floods, embankments have been constructed along the length of the river. This work, along with construction of a barrage at Hanuman Nagar, was taken up in the year 1957 and was completed in 1963. The various studies required for the construction of barrage, embankments and its protection in the form of batteries of spurs that you are looking at here was conducted on this model here.
One of India's great rivers is the Yamuna. Constructed in 1956, the Yamuna River model at the CWPRS has served as a template for attaining gainful insights into hydraulic structures like bridges and barrages and the flow they create. Here is a model explained by a CWPRS scientist.
We conduct alignment studies, location studies and the waterway and efflux due to these bridges and flood protection, if they are necessary, we conduct on this model.
We are standing on the deck of the signature bridge under construction. When Delhi government decided to make it an iconic bridge, we started planning in 2004. Apart from the many mandatory clearances, one of them crucial was clearance from Yamuna Standing Committee. To get the clearance from Yamuna Standing Committee, we required hydraulic clearance of this bridge, for which we approached CWPRS. When we approached CWPRS, their team came to site, had a stock information on site and did the hydraulic model studies on the model of Yamuna in their premises. The studies were conducted very fast in no time and we got the clearance as soon as we applied for it.
The fifth largest river in India is the Narmada. It is also called the Lifeline of Madhya Pradesh. Here is a model of the Narmada explained by a CWPRS scientist.
Now you can see the flow lines here. The flow is mainly concentrating on the left side and the right side bank is higher at about having RL of 15 meter and the left bank is about 78 meters.
Protection works, surge tanks, tunnel intakes for pumps and power plants are studied. Like in this model study of the Sardar Sarovar project on the river Narmada in Gujarat.
The Subansiri Lower Dam on the border of Arunachal Pradesh and Assam is the venue of a massive CWPRS project. The diligent CWPRS scientists are involved at every step of the research work for this reservoir and appurtenant structures. Here is a model explained by a CWPRS scientist.
Last 14 years, we have done very extensive studies for these projects to optimize the layout of spillway and to fine-tune the various design parameters of spillway energy dissipator and power intake. And we are also doing the scour studies as well as the schedule of operation of gates so that eroded material will not enter into the powerhouse tail pool.
CWPRS is a unique organization which has contributed tremendously in the growth of hydro projects in the country.
The rivers also bring a large amount of sediments in their course, forcing the river to often change their course over kilometers. This complex issue was successfully dealt with by building flow embankments, afflex bunds, and barrages.
Hydroelectric Mangdechu project, it is in Bhutan, 720 megawatt project. Sediment is a major problem in Himalayan region due to steep slope and fragile geology. This sediment, when it enters the water conductor system, it damages the mechanical parts and the turbines of the water conductor system. To mitigate these hazardous problems, diversion dams are provided to divert the water to the power intake, and orifice spillways are provided with a near to the riverbed so that the sediment is easily flushed out.
River flow measurements are vital for any planning and designs of water and power projects. These are done with current meters which are calibrated in CWPRS.
This is a fully equipped current meter calibration system. We can see here, we can just give this number of pulse of a current meter and the data of a current meters. Once that data is downloaded to the PLC, that is the programmable logic controller. Then we have to nothing that we have to just start the button in front panel. So trolley will move automatically as per the given system. Once we know the discharge or the volume of a water present in a particular area, water management policy or any type of studies, hydraulic studies can be carried out.
Canal automation in CWPRS. Here we have a 180 meters long model canal which is fully remotely controlled and monitored. All the gates in this canals are automatic gates, means they can be remotely controlled and monitored from a distance.
As the river joins the sea after running its course on the land, a whole new area needs to be explored. The CWPRS offers a surfeit of expert solutions, providing hydraulic structures like breakwaters, jetties, and berths required for the facilities.
We are on physical model of a Mumbai port at CWPRS. Presently we are looking at the Apollo Bandar at Bombay port. On the other side of it, we are having a naval dockyard which was built for the Indian Navy. Now we are able to see the various berthing facilities which are available at the Butcher Island, wherein the various types of ships which are bringing the oil to the Mumbai area are berthed. There are about 3 jetties very close to the Jawar Jeep.
For the Jawaharlal Nehru port, the container terminals are there, and the alignment of these container terminals is decided through the model studies.
(3D model, New Mangalore Port). This port on the western coast of India is an artificially developed lagoon type of harbour under development for the last 50 years. The CWPRS is involved at all stages in the development of this model. Systematic studies for comprehensive disaster management have been a regular feature at the CWPRS. Here is a model explained by a CWPRS scientist.
Used for hydraulic design of coastal structures such as breakwater, grants, seawalls, or for development of ports and coastal protection work. The objective of these waveflow studies are mainly for stability of the coastal structure. Initially, conceptual design of these structures are worked out by empirical method, and suitable armor units are used. Example: a tetrapod, acropod, dolas, stones, etc.
Internationally, the CWPRS footprint has spread its wings far and wide. Pasir Gudang Power Station, Malaysia, Port of Singapore, Southern Jaw Spillway in Burma, and Trishul project in Nepal have based their projects on the fruits of research concluded at CWPRS.
I am sure CWPRS scientists would continue to provide optimum solutions to future challenges in water and power sector and support designers and planners of Central Water Commission for all times to come.
A calculation of the flow in hydropower plants is measured at the CWPRS, which has the largest capacity of flow meters in India. Calibration of flow meters, CV testing of walls, and head loss of filters is also calculated with high-end precision. This is the Structural Modeling and Analysis Department. The laboratory is the heart of CWPRS. Here, high-quality instruments and equipment offer Team CWPRS the cutting edge and the much-needed vigor to continue their remarkable research for scientific progress of the community in general and the nation at large.
In the Geotechnical Engineering Division, we test soil properties to undertake the analysis of safety and stability of structures like earth dams, rock, then hill slopes and coastal structures like breakwater and their foundations.
Remote Sensing Application Center. This division has 13 workstations and looks into coastal erosion and river bank line detection. Advanced software equipment makes the complex calculation a definable reality. Demonstration room. The monumental work carried out by the CWPRS scientists and engineers is made available to visitors. The hydraulic projects, through hydraulic modeling, are on display at the venue. The room creates general awareness of the capabilities of the CWPRS team through the display of mini models and mirrors CWPRS's standing as a premier institute of its kind in the world.
The present challenges of river pollution and frequent drought in the backdrop of climate change requires extensive research and solutions. The CWPRS scientists would require to revitalize them or reorient themselves with acquiring state-of-art knowledge, technologies and fulfill the mandate to provide optimal solutions for achieving sustainable development goals in the changing climatic conditions.
CWPRS undertakes studies for micro-earthquake surveillance, where a network of micro-earthquake recorders and also known as seismographs is established at the dam site. The data is analyzed to get the magnitude and location of the earthquake events.
Then we have vibration engineering, then non-destructive testing of civil structures, then non-destructive testing of masonry structures like it. Now here you can see where the instrument used for control blast studies, where we have to excavate for various purposes, for dam foundation, for nuclear powerhouse sites and other things, where we have to see the safety of the structure surrounding this blasting site. So we recommend them blasting patterns for safety of structure.
This basin is there where actually containers are going to come, and these breakwater structures have been tested in the model.
And just now we are doing the studies for dry bulk cargo terminal off Tekra for the Kandra Port Trust, and we are trying to reproduce the waves from WSW direction, which is the predominant directions, and we are studying the wave tranquility aspects for the alignment of this dry bulk jetty.
This is a mathematical model for simulation of wave propagation inside the harbour. Here we can see that the model simulates all the important processes such as diffraction at the tip of a structure, that is turning of these waves, then reflections from these harbour boundaries, then refraction that takes place due to the changes in the water depth.
The CWPRS is taking every step to help the country meet its need for basic and applied research in water resources, power sector and coastal engineering.
Central Water and Power Research Station, that is CWPRS, is the apex research and development institute in water and power sector. Almost all important irrigation, hydropower, water supply, navigation and ports projects have imprints of this institution. Owing to its receptivity towards incorporating new technologies with the changing times, the CWPRS journey has continued ceaselessly over a century, earning it the stature of a world-class water and power research station.
For CWPRS, the glory of the completion of 100 years is only the stimulus needed to maintain the lofty standards we have always adhered to.
We are upgrading ourselves for becoming center of excellence in testing, calibration and training of hydrometeorological and water quality instruments under National Hydrology Project. We are also undertaking systematic studies for river rejuvenation, for prioritizing actions for optimum results. Disaster management planning, integrating inundation modeling with disaster management action plans and dissemination of traditional water wisdom through development of appropriate models for upscaling all across the country are the priorities for us.
A well-equipped library at the CWPRS is a guiding light for the research team at the institute.
As you know that the United Nations has adopted Sustainable Development Goals for ensuring access to water and sanitation for all by 2030, and CWPRS, being the apex research and development institution in water resources, has taken upon itself the onus of undertaking applied research in all related aspects and provide implementable solutions to the country.
The CWPRS management provides an ideal support system for the hard-working scientists and research workers by offering quality recreation and bonding facilities. A core team of dedicated researchers, including engineers, scientists, technical and other support staff at CWPRS, committed to the noble cause of nation building through scientific advancement, means the world to India's progress. As we relentlessly forge ahead, Avirat, 100 years and beyond, Athak, service through research, Atulya, incredible CWPRS.